So thanks to everybody for joining us for our webinar today. We do these every other week here at Astronomer on topics related to using open source Airflow. Super excited today to have Manmeet join us from our field engineering team. She's going to talk about the anatomy of an operator, so how operators work under the hood and how you can customize them for your use case. So obviously a very broadly applicable topic to lots of people. So we're super excited to put this on and learn more about that. Before we get started, just a couple of housekeeping notes. So the webinar is being recorded and it will be sent out along with the slides and any code that Manmeet goes through. So those will be emailed to you afterwards. No worries there. Definitely ask questions throughout. You're free to throw those in the chat. Again, make sure that you change your chat to send messages to everyone so that everybody can see your comments. You can also use the Q&A feature in Zoom. That's a little easier for us to track questions. Definitely throw those in. I will be answering them throughout as much as I can, and otherwise we will have some time at the end for Manmeet to answer any questions. Let's see, I think that is it as far as housekeeping goes. So like I said, I'm super excited with that. I will go ahead and hand it over to Manmeet to introduce herself and get started.
All right. So, hey everyone, I'm Manmeet from India, Mumbai, based out of India. I'm part of the field engineering team at Astronomer. And today I'll be talking about the anatomy of an operator. I really like this word, the anatomy. I never thought I'll say that. It's more of a science word, but I just love the sound of it, the anatomy of an operator. So yes, as Kenton mentioned, we are going to talk about how an operator works under the hood, how we can extend it, and how we can make it useful, in our regular use cases that we have using Airflow, right? So the agenda for today is just a brief overview about operator, what it is, what is a base operator, how do we create custom operators, how are hooks and operators related to each other, and what are callbacks, and then any questions if we have, right? So let's move on. Let's talk about operators. So if I have to define operators, I would say they are the building blocks of a DAG in Airflow, of an Airflow DAG, right? And what you want to do, from like what you want to achieve as part of your daily job is something that you define in an operator. And once you do that, once you define what you want to do, it makes a task which makes it appear on the Airflow UI. So let's move on to the next slide and see how it will actually look on your Airflow UI. So this is a screen grab from the Airflow UI of a very simple DAG, which has 5 tasks. And task, as you know, basic unit of execution of a DAG, which they are stitched together in a logical grouping of a task makes the DAG. But how does a task appear on the UI? What actually is running behind the scenes of a task is actually we are going to talk about is the operator, right? So task versus operator. Let's just look deeply into it. Like, how do you implement an operator which actually makes it into a task? So operator is basically a Python class, which is under the hood, extended from a base operator class. So any Python method that you want to write, you can actually call it using the Python operator, for example, and it will appear as a task on the Airflow UI. Now, starting from Airflow 2.0, we have the TaskFlow API as well. So these 2 screenshots of the code that I have are actually the same thing. This is using the TaskFlow API, which is under the hood, the decorator is calling the Python operator. And this is something which is like separately we have written, okay, I'm calling the Python operator. This is the method that I want to call. And what I want to do as part of my operator, I have defined in a function and I'm calling it via the Python operator. So when I implement this operator, that means when I instantiate this class, a task gets created in my Airflow UI, which is actually rendered as part of the DAG, right? So when we implement a business logic, what I want to do in an operator, it shows up as a task. Now, there are another thing is, in an operator, you can actually define what you want to do, or you can also call an external system to run a particular job. For example, in this particular case, I'm just printing some statements. For example, I want to read a CSV file, load it into a data frame, and maybe count the number of rows. So I'm defining the action that I want to perform in a Python method, which I can call via an operator. Whereas in an operator, I can also call an external system, let's say a DBT cloud job that I have, or I have a job which is in BigQuery, which I want to execute. So I will be utilizing the BigQuery API or the DBT Cloud API to trigger that job. So basically, data orchestration is what Airflow fits the bill in the data landscape. So we can use an operator to take some action on the data that we have, or we can trigger something else in an external system to complete that action, right? And one operator has a one-to-one relationship with the task. So we have an operator. This is something that will be visible as a task on my Airflow UI, right? So in a nutshell, operators are where you define the actual work that is to be done. Then there are different types of operators, right? Operators themselves, like I mentioned, define the work. Then there are subtype of operators, which is called sensors. A sensor is where you define a certain criteria, which when met based on an external event, it means it marks it as failure or success based on the condition. So you define this criteria. Let's take an example for this. For example, I have an S3 hook. There's an external system which needs to send a file to me. So I want to wait for that file before I trigger my data pipeline. So I can use an S3 sensor, which will look for that file. And once the file is found, then only it will mark it success. If it is not found within the time that I've defined, it is going to fail. If it's going to succeed, it's just going to trigger the pipeline ahead of it, right? So sensor is just a subtype of an operator whose sole purpose is to make it success or fail based on the certain criteria that it's watching. So basically, it's watching an event that's happening. Next is transfer. This is again a subtype of an operator, which helps us transfer the data from one system to another. So for example, let's take, if I have to move the data from a GCS bucket into BigQuery, right? Two different systems. Or I want to move the data from S3 to my GCS bucket. Or I want to move the data from S3 bucket A to bucket B, right? So I will utilize transfer operators. And all the operators are derived from the base operator class. So base operator class is something which is an abstract class which cannot be instantiated. So all the operators that exist in Airflow's environment are extended from base operator, and we can create our own operators as well by extending the base operator class, right? And as you all know, extensibility is one of the most powerful features of Airflow. It allows you to build your own operators, use your own code, rather than repeating it at different places. You can just create your own operator and share across your organization, even contribute to the community, back to the Airflow community. So base operator, like I mentioned, base operator is an abstract class for all the operators. You cannot instantiate a base operator because base operator does not have the execute method implemented, where you actually define what you have to do. So in order for us to create a new operator, we need to extend the base operator and override two different methods. One is the constructor method, which is the init, and another is to implement the execute method, right? In the execute method, all the code that you want to do goes, and in the constructor, all the variables that you want to instantiate, they can go over there. Another thing is, either you can extend a base operator, which itself does not do anything, but you can also extend any existing operator to extend its functionality. So we'll take an example of both these cases where we implement a base operator, we create a derived class from that, and also extend an existing operator to extend its functionality, right? And in the further slides, we are also going to look at callbacks and how callbacks work and about the task state diagram. Another important part is do excom push. So do excom push is a property of a base operator, which by default is set to true, which allows each operator to return some information to the caller, right? So if you have tasks stitched together and you want your task to send the information, whatever it has processed, to the next task, do excom push should be set to true. If you do not want to send that, you can set it to false, right? So you can always override this to false if not required, because by default it is set to true. Okay. So before actually talking about how we extend operators, let's talk about hooks, right? So hooks are something, which act as an interface between your external system and your Airflow. So let's take an example, a very simple example. I have a requirement to process some data from a Postgres database, and I want to be able to connect to the Postgres database and then read the data. Now, in order for me to connect to that Postgres database, I would need the host, I would need the port, the credentials, and other parameters. And using those, I'm going to create a method. Let's suppose, define connect to Postgres, and I'll use the library psychopg to connect to the database, right? So this connection, this method that we define, right, in Airflow terms, it's actually called a hook. So if you're familiar with Airflow, you are familiar with the connections UI, where we define all the connections. So hook is something which actually uses those connections to create or set up a connection with an external system as defined in the connection object, right? So hooks are something which is used within an operator, which help us to connect to an external system. And once it is connected, you can, run your own code and, do some operations on that, right? This external system, like it can be any REST application, any database, any cloud storage, like S3 hooks are there, BigQuery hook is there. As an example, we have G Sheets hook as well, which allows you to connect to Google Sheets, right? So how you interact, how you talk to the external system is something that hook creates. It creates that connection with the external system. So this will help you to actually separate out the logic, what you want to do in an operator, and how do you connect an external system separately in a hook, so that both of them stay separately and you can utilize a hook at multiple places. And even you can also create your own hooks if required, just like operators are there. Right. Now, let's talk about extending operators. Excuse me. So we'll take a use case, take some examples, and then we'll take an example on how to do that. So let's say I have this particular example where there's a system called 59, which I want to connect to, but there is no operator that exists. Right? So I can write my own operator, which connects to 59. And maybe if I want to contribute to the open source community, I can. If I don't want to, I can just use it multiple times within my organization. So let's say I have 5 different data pipelines, which pull different reports from 59 system, right? I can just create an operator once, and I can create it the way that it just takes the report ID and the connection ID. That's it, right? So this operator would be helpful for me to use in multiple different DAGs. And I can, we don't have to reinvent the wheel. We don't have to copy over the code from one DAG to another DAG. Another example is, which is like very, very common, where we have some repetition of code. So this is very similar to the concept of object-oriented programming, where you modularize the code, where you, for the ease of debugging and maintaining the code. So for example, you have a SQL query, which is supposed to run against the database. You want to store the data into a temp table, and then you swap it out with the target table, right? Before actually that table gets used by the business. Then you can, if I have 50 pipelines, I would have the same code appearing in 50 pipelines, and any change that I would have to do, I would have to do in each and everything. But what if I create an operator out of it, which will do all this functionality as part of one task, because that's the grain I'm looking for. Then I just have to define it once and use it many times, right? Another is, like I mentioned it earlier, it, already an operator is existing, for example, S3 copy object operator, and we want to add a functionality on top of it. So in this particular case, let's say I'm using S3 copy object operator to copy over some files from my external S3 bucket to my internal S3 bucket, right? But what I want to do is, other than just copying, I also want to capture the name of the file, the timestamp when the file was copied, the source bucket name, and the target name into my metadata database for capturing data lineage, or some sort of logging information or monitoring that I have to do later on. So what I can do is I can actually extend my existing operator, just use the execute method that is defined there, and add the functionality to capture that that additional information, right? So we'll see an example of these in the next coming slides. So let's talk to this example, which I was explaining, where we have a SQL statement. Data analyst has given you a SQL statement. You have to, make sure that it is executed and shows up nicely in your dashboard, where it is hooked up to a report. So I have a SQL statement which needs to be executed. I need to execute it in BigQuery. I have to save the results to a temp table. Imagine I also have to do some DQ checks on that table. And once it is successful, I have to swap out the target table and the temp table. If the DQ checks have failed, I do not touch the target table, right? So this piece of code that we can see is the vision that I have. Okay, it should be so simple that I can just write SQL transform operator. This is the task ID. Sorry. And this is the connection ID and the table name and the schema name that we have. So I can just define this, and my code, automatically the code that I write in operator should do all this functionality that is mentioned over here. So let's take a look at an example. All right. So I have an example for the DAG that we just now discussed, where if we, okay, I'm just going to zoom in a bit just so that it's visible. Okay. So I have a transform method, which I have decorated with the @task decorator. That means it is using Python operator behind the scenes. I'm just reading a SQL file. Then I'm using BigQuery hook to actually run that SQL query, which is going to save the results into a temp table, right? Then I'm performing some DQ check that I've defined again in a SQL query. If the checks are passed, then I run the query, which actually swaps out my target table with the temp table. If it doesn't, it just raises a value error, right? So let's just take a look at how this DAG looks on the UI. Okay, so this is my DAG, and like it's just checking, okay, API is active, read API data, upload to GCS to BigQuery, and then my transform method. Now, this looks like a very small task over here, but if you look at the code, as we saw, it is like at least 20 lines of code that is there. This is just for testing, right? So imagine tomorrow my organization decides that we want to move away from BigQuery and we want to move to maybe Redshift, right, or Snowflake, or I have to add multiple DQ checks, or I have to change the logic in which if checks are passed, I need to log them to a different database, even if it's passed or failed. I want some logging and monitoring. So imagine if I have this piece of code in various different pipelines, then any changes that I have to do, I have to go and do in each of these pipelines. So I don't want to do that. So what I want to do is I want to convert this entire piece of code into an operator of its own and then import it into my DAG. So let's go to the code. So I have created a transform operator, which basically, as we can see, has as you see, two methods have, I'm actually deriving this new class from my base operator. And I have a constructor method and I have an execute method, which I need to override. So in my constructor method, I'm just calling the constructor of my base class, and also initializing the additional parameters that I want to pass, which is the connection ID, table name, schema name, and this is a default variable, right? And then I have an execute method, which will contain the logic that I have in my DAG, right? So what I've done over here is I've copied over this entire logic from here, right, into my transform operator, right, over here. That's it. Nothing else I've done. I have imported the base operator class. I have created a new class. And then in my existing tag, what I'm going to do is, let's just see this. Okay, so I'm going to comment this part out. Then I am going to put this thing in, which is the SQL transform operator, which is the same operator that I created, right? And I'm going to change the call to this. This is my new task, which is calling my SQL transform operator, which I am importing from the new operator that I created. Now, remember, whenever you are creating a new operator, Airflow by default looks for the operators in the same directory where the DAGs are there. So its reference point is that. So make sure whatever path that you have your operators, your custom operators in, it's actually part of the Python path, right? So in this case, what I have done is I have a directory called plugins, in which I have created a subdirectory called operators, in which I have put transform operators. Similarly, you can, within plugins, you can create hooks or something like that, or you can just create subdirectory within DAGs. So like whatever makes sense for your directory structure, but just make sure that the file is on the Python path from where you want to import it, right? So what I've done is a couple of steps. I have moved the code within that Python method into a separate file of its own. I have called that operator in my DAG, right, and made the call to that particular task. Now, if you go back to the Airflow UI, so if you can see, nothing changed in my DAG. It's exactly the same. I've made sure that I rename the task ID that I'm using is the same ID, but you can choose whatever you want. But if you look at the code over here, it has now picked up my latest code, right? So what this makes it easier for me to debug, maintain, this particular code, and it makes my DAG code really concise. Yeah. So this is how you extend an operator from a base operator. Now, let's take an example of where I mentioned like how you have an existing operator, but you want to add upon the function, add to the functionality of it. So in this particular example, if you notice, I have a read API data in which I am using an HTTP operator. So as such, there is no HTTP operator on Airflow. But what I have done is I have created my own class HTTP operator, which is actually extending simple HTTP operator. Right. Now, the reason that I did was simple HTTP operator in my use case was not sufficient for me because it was returning the data read from the API as an XCOM. Let's say I don't want to do that. I want to save the data returned by the XCOM in a file. So what I did is I just extended simple HTTP operator. I have another variable being passed to it. I'm calling its parent class constructor. And within execute, I am also calling the parent class execute. And on top of that, after the execute of the parent class is done, it is going to return some XCOM value, some data, which is read from the API. Then I am saving that data in from within Airflow in a local directory within Airflow, right? This is something then I will later use in my local file system to GCS operator, which is going to upload my file to the GCS bucket, right? So this is an example where you can have an existing operator and you can extend its functionality. And the other example we saw where we extended the base operator, right? So let's go back to our presentation. So we talked about this. Okay, we talked about this code. So coming back to hooks and operators, right? We touched upon hooks a little bit, how hooks are the interface for us to an external system, right? And how we use them within an operator. Now, if you see over here, there are many hooks that are existing. For example, we talk about BigQuery hook, right? So I've used two methods over here from the BigQuery hook, like run underscore query. Then I have get pandas underscore df. Then I've again used run underscore query. Now, many times we use a hook, as we don't directly use a hook. If I'm using a BigQuery operator, I might not need to use a BigQuery hook. But in this case, I'm creating my custom operator and I am using BigQuery hook. And there are cases where I need to use the methods that might be actually already defined in the BigQuery hook. So for example, we are seeing run underscore query. There is a run underscore copy. There is an insert underscore job. There is get underscore records. And there are many more, which are already implemented for us. So we don't have to reinvent the wheel by writing the same code again in an operator. As an example, just this is a screen grab from the S3 hook, which has methods for check for bucket, get bucket, create bucket, and there are many more, right? So whenever you're using hooks in a custom operator, then before implementing something which requires you to bring something for your source, check out the hook code, whether it is something is available out of the box, which you can easily use within your operator. Just like get bucket, I didn't know it existed, right? So it just helps to check if I want to do some operations on the bucket for which I do not have an operator. I could use the S3 hook, then use the object returned by this particular method, right? So hooks and operators are like go, so tied together, go hand in hand, especially when you write a custom operator. Do remember to check out what are the methods that are available in the hook, not just the regular methods, but there are other helper methods also available. Next is template field, right? So there are cases where, I don't want to hard code everything. I want to have some dynamic data flow into my SQL query or some parameters that I've defined in an operator or my, a shell script that I'm executing. So how do we do that? So Airflow uses Ginger templating, which is a type of templating engine widely used in Python. There are many others, but Airflow relies on Ginger templating. So it allows us, as an example, look at this code snippet where I want to show, okay, today is this date. So I can use execution date rather than writing a method separately or writing a bash function, which is going to pick up today's date and extracting out the value. I can rely on the execution date, which is a value that is available to each of my Airflow DAGs. I can pick up the day from that. This is very useful, especially in cases where, let's say you are API data. Let's suppose we take the same example. We are reading the data from the API, and my job is running daily. Every day, I want to store the file that I'm reading in a separate directory, right? In a S3 bucket or a GCS bucket. So I want to make sure the path is different every time. So I can rely on execution date to grab the YYYYMMGD part and create that path within my S3 bucket and store the file there. Or I can name the file like that. So the how you want to customize your parameters, how you want to customize, let's say, if I put the same statement in a shell script, right? I can actually just, the Ginger templating is going to expand the same thing in the shell script. Even the SQL files. So for example, if you want in your SQL query, you want to rely on execution date to pull up some data from a table. You can use Ginger templating in your SQL query, and Airflow is going to search, expand that value for you. And a template search path. So template search path is basically a little bit tied to the same thing that we discussed in the previous slide, where Airflow by default looks into the DAGs directory for all your SQL files or scripts or something. But let's suppose you have your SQL files somewhere in a different repo and you don't want to put it in your Airflow repo. And you have downloaded those in a different directory. So you can edit your template search path, which remember this is template search path is something which is not available at the task level. It is available at the DAG level, where you can say, okay, I want to look for my SQL files in /data/SQL or something like that. If you don't specify that, it will by default look into the same Python path that is available. Right. Then callbacks. So before we talk about callbacks, let's look at this task state diagram. So we all know how the tasks in Airflow transition from, no status to a scheduled status, then a queued running, then it could be success, a failure, or maybe up for retry, right? So we just saw another DAG in which everything was green because that was already successful. But let's suppose I trigger a new DAG, or a scheduler picks it up. Initially, it is no status, then it is scheduled, then queued. So all these changes of the state of a task is the state change that you're referring to. And it is important for the callbacks because callbacks are something which are actually triggered by this state change if we have configured them, right? So not all of the states are available for callbacks. So the ones that we have available are on execute, on success, on failure, on retry, or SLMs, right? So what do callbacks do? So on execute callback is something, let's suppose I want to capture the start timestamp of a task when it starts running in my own metadata database or in a log somewhere. So on execute callback will allow me to call that Python function, which actually takes the maybe current timestamp, and I can put in the logic that I want to write this into a log or into a metadata database. It will be executed before my execute method in the operator gets executed. Too much of execution. So in a nutshell, callbacks allow us to invoke regular Python functions based on the state change of a task. But remember, only the state change that is triggered by the worker is something which, which causes the callback functions to be called. Like, for example, if I go to the Airflow UI and I change the status of my tasks from success to failed or failed to success, that is not going to trigger the callback methods. But only if a worker is executing and if the task fails, if I have defined on failure callback, that method is going to be executed, right? So they are very helpful in logging monitoring. Like I mentioned, if you want to capture like some information about how much time does your task takes, and you want to log to your own database, which your organization uses for some monitoring, or you want to send out a Slack notification on a failure, or you want to send out maybe a PagerDuty alert if it's a retry, or you want to send out a success email to a customer, maybe that they have sent a file and it's successfully loaded. So that is where callbacks are very useful. Then there's another callback called SLA miss callback, which is actually only available at the DAG level. What it does is, so DAG level code also has a parameter called SLA, which we can define as, let's say, in minutes or in hours, that it is going to take, let's say, 30 minutes for my DAG to be executed. This is what I'm anticipating. If I miss that SLA, then if I have defined SLA miss callback in my DAG, it is going to trigger that method, and maybe I, send a PagerDuty alert saying, okay, you know what, I missed this particular DAG has missed its SLA, so maybe it's something to look into so that reporting won't be affected, and so on. So it all depends on your usability, on how you want to configure it. To take an example of this, like this is a regular, Python function in which I have defined a custom failure function, which says, just prints the error for now about the task. And how do I call it in the default task? I've mentioned on failure callback custom failure function, right? Maybe I could have a Slack notification in this, or let's say another external system sent us some files. I do some DQ checks on that file, and if those DQ checks fail, based on the data contract that we had set up, I can set up a custom failure function to send out an email to the third party saying, you know what, something is wrong with the file. We need a new file, right? So the best part is you can customize as much as you want. You can extend the operators. You can tweak the settings per your requirement and keep on using Airflow for all these wonderful features based on your business requirement and how you want to use logging, monitoring, or you want to moderize your code, or you want to just use the providers or operators that are, already available. Yeah, that's it. Thank you. Any questions?
Awesome. Thanks, Mamie. That was a ton of great information. We have so much good activity in the chat and people indicating that this was really helpful for their use case. So love to see that. Thanks for going through all of that. We do have a couple of questions that I have not answered yet, so we'll go through those. The first is, can you clarify when you would want to use the task decorator, so the Python task decorator versus implementing a custom operator? Those are kind of two different use cases. Maybe you can expand on that a little bit.
Yeah, absolutely. So let's go back to the slide we have over here. Right. So yeah, two different things like Kenton, you mentioned. So the Taskflow API just makes it easy for you to write an Airflow DAG. Honestly, it's as simple as that. For example, I have a DAG which reads a file. Let's take same example, but reads. I have a Python program, not a DAG. Let's say I'm new to Airflow. I have a Python program. I was using cron job earlier. So I'm reading a CSV file. Okay, this is my first method. And then I am loading that into a data frame, my second method. Third method is I'm printing out some of the variables, some of the column in that, right? Now I've got Airflow. My manager told me, okay, now you have to convert this to an Airflow DAG, right? All I have to do is I have to import, let's say, I have to import the decorator, DAG and task, and I have to use those decorators on top of my existing Python code, which will convert my Python functions into an operator. So a task decorator behind the scenes is using a Python operator, which is actually a class, which is extending base operator, right? So it is different from this discussion, okay, when should I create a new operator? A new operator is something that you can create based on your business requirement. Like I mentioned, I have redundancy of code here. I can see that I have already 10 pipelines which are using the same code. I don't want to do that. Tomorrow something changes. I don't want to go to 10 places. So I decide, okay, I can create a different operator. So no hard and fast rule over here. It all depends on your business use case. Whether you want to extend the functionality like I did for my HTTP operator. Now, let's take another example of Python operator. So you have a Python, the Python operator is just going to execute your, whatever Python method you have given. But I want to, every time a Python operator gets called, what I want to do is I want to write to a special log somewhere which goes to Datadog that this Python operator has been called, some message, some data timestamp. So what I can do is I can decide on, okay, I want to extend Python operator and add that functionality just like I did for a simple HTTP operator over here. Because simple HTTP operator did not suit my requirement. I wanted to write to a file and not return a value, right? I hope that makes sense. Both are two different use cases. So you can easily convert task in a nutshell. Taskflow API allows you to convert, your Python program very easily into an Airflow DAG. Whereas whether you want to create new operators, extend new operators, all depends on your business use case, whether the operator exists, or you want to extend the functionality, or you want to remove redundant code and put it into a single operator because it actually suits a single task, right? But don't try to club together too much information, into a single operator, because it should be all aligned to what you are trying to achieve as part of your business goal or your problem statement. I hope that made sense.
Yeah, that was great, Manmeet. Super thorough. Just to summarize all of that great information, the task decorator is relevant if you have Python functions that you're running and it's more of a stylistic preference over using the Python operator explicitly. Custom operators are obviously going to be good for everything that Manmeet has talked about today. So any additional use cases. So that's great. I have one other question that hasn't been answered yet. Mindy is asking if there's a hub where we have pre-written extended operators that can be used directly. So in general, those are anything that's going to be pre-written that you can just plug into your DAG is going to be part of a provider package. At least that's how you can be confident that you should use it in your DAG. So the easiest place to look for those is going to be the astronomer registry. I will post a link to that in the chat in just a second. But that's going to show you, give you a place to search for any sort of pre-built operators that are already part of a provider package. If you need to go then extend those, that's where you would, follow with everything that Manmeet has talked about today. I'll also throw out there related to that if you extend an operator in a way that you think would be helpful to other people with a similar use case, you can always contribute those back to a community, either through a new provider package or as part of an existing provider package. So that's a great way to contribute to Airflow as well. Let's see, we have one other question that has come in. Neat. So in the example that you used, you had your SQL queries found in separate, .SQL files as opposed to in your DAG file directly. Is there kind of best practice for keeping these SQL files up to date, or what can you say about kind of organizing your project structure in that way?
Yeah, so good question. Actually, I should have touched upon it while I was walking through. I'm sorry I missed. So it depends on how you want to structure your DAGs. So in this particular, like we have actually a very good guide on how you actually want to structure your Airflow DAG repository. In this case, what I've done is I have put as I mentioned earlier, by default, Airflow looks into in the Python path wherever you're looking for SQL files. So for example, in this particular file, I've mentioned, just get the current working directory, go to DAGs, and then in DAGs, I have a SQL subdirectory. But you don't have to do that. Generally, what we also say that there's an include directory that we have. You can create a subdirectory for SQL and put your SQL files there so that they stay separately. Or you can just, within your DAGs, you can create a SQL directory. And within the SQL directory, you can also have a subdirectory for your DAG name, right? But putting them together in within a SQL directory is important so that it's easier for you to manage, right? There are cases where people have put their SQLs, let's say, if I'm part of the analytics team member, I just want to put my SQL file in a separate repo. And in that case, you can customize your Docker image, kind of segueing from this topic, and you can clone that particular repo in your Docker file and then use template search path for overwriting your SQL path. But for now, as a best practice, we would advise you to either whatever directory you choose to put your SQL files, you make sure that it is on the Python path. In this case, I have put in a SQL directory within the DAGs, right? And you can also put it in the include directory as well. Does that answer your question?
I think so. That was a great follow-up. All right, so we don't have any other questions yet. Since we have a few more minutes, I'll give everybody maybe 1 or 2 minutes. If you have any questions for Manmeet, throw them in the chat or the Q&A now, and we'll be happy to answer them. This was a lot of great information. I know we've had a lot of requests for the recording afterwards that will be available on our site as well as via email, as long as you consented to receive those. So we'll be able to reference it later. Question on, can I find the guide on structuring the repo? Yeah, so Mamie, we've got a couple of resources around that in general on structuring your repo. We're also going to have an upcoming webinar. I believe it won't be until September, but on kind of that topic in general. But Manmeet, is the code that you showed today as an example available in a public repo that folks can reference kind of as an example?
Yeah, I think there is a guide which I can put. I can in the references slide over in this presentation. I can put that link and everyone can refer that. I've already put some references which whatever I've referred for this. So yeah, whenever this PPT is shared, you can refer that.
Awesome. Yeah. Great help for everybody. Well, thanks so much, Manmeet. This was really great information today. I know we all appreciate you staying up late to go through this and answer everybody's questions. Thanks to everybody so much for joining. Really appreciate it. We do these every other week, so definitely hope to see you again, and always feel free to contact us on our website if you want to chat more about your use of Airflow and your use cases. But with that, we hope that you all have a great rest of your day, and we will see you next time.
Thank you everyone. Thanks, Kenton. Bye-bye.
Bye.